Okay, let's dive right into one of the most fascinating concepts in computer science. Today in this explainer, we are unpacking exactly why Java is famous for being platform independent. And to do that, we've got to talk about the sheer magic of bytecode.
Now just wrap your head around this number for a second. 3 billion. Oracle estimates that Java is currently running on over 3 billion devices worldwide. We're talking everything from your daily Mac laptop all the way up to massive enterprise-level Linux servers. It is literally everywhere.
So that begs the obvious question, right? How on earth does one single programming language manage to speak to 3 billion completely different devices? Back in the early days of programming, you couldn't just do this. You actually had to completely rewrite your code from scratch for every single specific operating system architecture. Honestly, it was a total nightmare for developers. Enter James Gosling and the team at Sun Microsystems back in 1995. They set out to fix this exact nightmare, and they did it with a really bold, iconic promise: write once, run anywhere. That phrase became Java's core philosophy and its ultimate promise to the software world. To really get why this was such a game changer, you have to look at the difference between traditional machine code and what Java did. Traditional code is fast, sure, but it strictly locks you into one single operating system. Java, on the other hand, skips compiling directly to that rigid machine code. Instead, it compiles to this brilliant platform-neutral middle ground, and that is what we call bytecode.
Let's break down exactly how this builds out in practice. First, you write your standard .java code file. But then, rather than compiling it down for a specific host machine, the compiler converts your code into a universal .class bytecode file. Once you have that intermediate file, boom, it's ready for the final step where it gets read and executed. I always like to think of bytecode as a sort of universal translator. It's kind of like taking a book and translating it into Esperanto. You don't need to translate it into French, Spanish, and German individually. You just make it Esperanto, knowing that as long as there's a local interpreter around who knows that universal language, they can read it perfectly to whoever is listening.
The Java Toolkit, demystifying the acronyms. Because let's be honest, to make this whole universal translator thing actually work, Java relies on a toolkit that looks like absolute alphabet soup when you first see it. So let's quickly break it down. Okay, so looking at how it maps out, you've got three main pieces. The JDK, or Java Development Kit, is for developers. It's the builder that compiles the code. Then there's the JRE, the Java Runtime Environment, which provides all the necessary libraries for users and devs. But the real MVP here, the absolute core of the whole operation, is the JVM. That's the engine. The JVM, or Java Virtual Machine, is exactly that local fluent interpreter we were just talking about. It's the specific piece of software installed on your device that takes that platform-neutral bytecode and translates it directly into native machine code, right on the fly for your specific Mac, Windows, or Linux hardware. And if we peek under the hood of the JVM, you'll see it actually sets up its own completely dedicated environment to do this safely. It uses what's called heap memory to store all your newly created objects, and stack memory for local variables and methods. Then the execution engine just goes to work, running that bytecode flawlessly.
The grand caveat of platform independence. Because, every great engineering solution has a bit of a twist, right? Java's massive claim of being completely platform independent actually comes with a tiny but incredibly vital asterisk. Here's the catch. Write once, run anywhere means your code is independent of the hardware, sure, but you've essentially just shifted the dependency from the code itself over to the environment. Your code can only run anywhere, provided that anywhere already has a Java virtual machine installed and ready to go. It really is a brilliant workaround when you think about it. Java solved the cross-platform problem decades ago by shifting the dependency from the code to the environment, which leaves us with a really fascinating thought to ponder. In today's modern world of cloud computing, Docker containers, and microservices, where we are literally constantly packaging environments with our code, how will the legacy of the JVM and bytecode continue to shape the way we write software tomorrow? Something to think about. Thanks for joining me for this explainer.